My name is Nourhan Mohamed, and I hope today is going to be a very beneficial talk on AI, on Kubernetes without the chaos, because all our lives are about chaos in IT. So let's help reduce the chaos, and thank you all for being here. So let's start. So this is just a little bit about myself. My name is Nourhan, like I said, and recently, and thankfully, I was able to continue my journey towards the Golden Kubestronaut. I finished that, and I am a DevOps lead at my beloved company, KodeKloud. And my expertise is about virtualization. So I started off at Dell as a technical support engineer. I built up my way virtualization, containerization, and then Kubernetes as a manager of Kubernetes platforms in VMware, and then I moved to KodeKloud later. So by now, I have a good amount of knowledge about Kubernetes and cloud-native platforms, and as we are all new with AI and ML, so we are struggling, everybody's struggling in this environment and in this platform, so let's try to explore options for all the problems that we are seeing. So let's dive in. So let me start by a number, 300. Take a look at that number, and 300 is the amount of machine learning papers that detected data leakage affected by reproducibility. So 300 is a big number in the research world. And this paper has been published in 2023, but if you have been around today, if you have attended the keynote this morning, our friends over in NVIDIA were just saying something like that they still struggle, some people still struggle with reproducibility until now, and we're still researching options into how to improve that, how to build reproducible and reliable machine learning workflows. So today, we are going to explore some options into how we can fix this. So what's about the reproducibility problem? What do we mean by reproducibility? So just to make it easy, I'm going to stay away from machine learning for now and just tell you a small story about my friend Bob. So my friend Bob has a sweet tooth. He was sitting in his room, and he remembered that last week, he ate that cupcake that was amazing at one of the restaurants. And that cupcake, he kept dreaming about it every day. So he said, after lunch today, I'm just going to head back to that restaurant and have that cupcake again. So last week, when our friend has gone to that restaurant, Chef A was on duty. Chef A had some ingredients, they mixed it, they put it in the oven, and then after they put it in the oven, they got that lovely orange cupcake. And then today, when our friend Bob went to the restaurant, that happened. Chef A wasn't available really, so Chef B actually went into the kitchen, used the very same ingredients, which we can see here, but tweaked it a little bit. So maybe used a little bit eggs, increased the flour a little bit, stuff like that. And then added everything in the oven, but used the pretty lower temperature, but ended up getting a nice cupcake, which was green. Our friend Bob got to taste both, 1 week difference. But he doesn't really feel like this thing is the same that he tasted last week. Although we have used the very same things. We have used the inputs, used the same machinery, but produced different outputs. So this is reproducibility. But again, why would we care about reproducibility, especially in machine learning? So in terms of data leakage, just a little bit about machine learning. Machine learning is that we have a data set and we'd like to infer or know knowledge from that data, know some attributes about this data, study this data, and then train a model, and this model can help us later either double check or fact check stuff that is new, that dataset, new datasets that we get exposed to against the trained model, or we would really need to infer new stuff based on the information that we really need. So what we do when we are training models is that we get a known dataset and we split it. We take a portion. This portion is going to be trained by the model. And then we hide another portion. This hidden portion is going to be our control. So we are going to test the model afterwards and see if it actually behaves like we want. But what happens if the model actually peaks on that data? If the model peaks on that data, then our experiment is ruined. The data that we have been gathering, everything that we have been working on, is now useless because the model knows the answer. It knows the final answer. So useless. We didn't do anything. It just can give you the predictions that you already know about. We would like to eliminate this. And to be able to eliminate this, we need to have a framework that we're going to work with to make sure that everything is reproducible while ensuring that data leakage does not happen. So, again, why we would reproduce stuff and why do we have to run multiple experiments? Why do I have to care about that? Can't we just train a model once and that's it? Actually, no. Why is that? Because our aim is not to just run the model and train it once and that's it. Our aim is to get the most efficient model that we have, the least cost, and the highest performance. And to be able to do that, we would need to feed it different inputs, and then get different outputs, and then evaluate both, and see which run actually yielded the best results, so that we can deploy that to production and actually use it later. So, as you can see here, if we could not have like a list of runs with different parameters and different associated outputs, we cannot compare anything. If you have some apples and some oranges, you cannot really compare them. We need something that has to track everything from start to end, and then we can compare stuff and make sure that this model that we settled upon is the best. Without this reproducibility, we cannot compare runs, and we cannot achieve this. So let's look first on the traditional ML workflow, the one that has been used for a while and the one that is actually causing problems, and see what problems do we have. If we know what problems do we have, then we get to enhance our processes, our workflows, and even achieve the results that we want. So to start with, machine learnings have been, when machine learning have started, we have all used those interactive, nice Jupyter notebooks. We would have a notebook, we would add some inputs, and keep running and getting the nice charts and the nice outputs. But there are some problems with these. So if we can see, once you just close your laptop, these are gone because they just live in the memory. So I restart my laptop, that's gone. I have a colleague at work, they restart that tomorrow. There is no way to know if I ran this, if they ran this. I don't recall which parameters I used yesterday. They don't recall which parameters they used today. So that's the first problem. Coming next, the same thing that I was saying, manual tracking. So let's say we are going to fix our issue by having a spreadsheet and maintaining it. So today, I'm going to run the model with parameters A, B, and C, and then I'm going to track that into an experiment. And then comes a day that my colleague decides that he's going to lose the bus today, and he would like to go home. So let's just skip doing that today. And then after tomorrow, somebody else decides that. And then after tomorrow, somebody else decides that. So we are missing runs, and maybe I forget my eyeglasses today and just decide that the 0.5 is 0.05. So there are errors that happen. When humans are responsible for something, human errors happen. Third thing is, have you ever seen that final V2 before? So this doesn't even happen in models only, like in PowerPoints, in models, in anything that we do. If we are not using something that is virgined, we keep on virgining stuff, and appending underscore final endlessly. And then we get lost, which is the actual final version. So that's actually a problem, because we cannot pinpoint that final version. Where did it come from? And if we cannot pinpoint how did I get that model, I cannot actually reproduce it. Next thing, OK, I have the model. Fine. I copy and paste the model on my environment, and then I run it. And then, because everything does not work as expected, it just crashes. But I don't have a version. I don't have versioning. So what do? I don't know. I just freak out. Pager duty, wake up someone at 1 a.m., and that's it. They hate me, but OK. And then, if I actually want that to be good, then I need a version to be able to roll back. If I don't know which model has been deployed, then I cannot roll back. Simple. Last but not least, we have all seen the "it worked on my laptop" issue. But here, it's actually a major problem. So it worked on dev. No, it worked on staging. Oh, production? Wow. Did we just push to production now? It's not working? Oh, my God. So how do we, if these are the problems that we have, how do we actually work on fixing them? If this is just deployed locally even, not even on Kubernetes, when we are going to deploy that on Kubernetes and start adopting the state-of-the-art things that the world have been creating beautifully, then this becomes even more chaotic. Why is that? So number one, you have version drifts. So you try something locally, or you try something on dev, or you try something on production, and each one has versions, packages different, OS is different, stuff that is different. So you have stuff that you cannot compare, because this version produced something that this version is not going to produce. Second thing, I have a broken pipeline. I don't have an automated pipeline, so I might run step 1, then 2, then 3. My colleague can opt for step 1, then 3, then 2. My other colleague can opt for step 4, then 5, then 1. So we don't know what actual steps we took to be able to produce something. All these things that happened can be summarized into two main problems. Like I said, environment and version drifts. Packages are not pinned. We don't know which packages we used, which versions we used, which environments we used for each build. And the most important thing is lineage. What is lineage? Lineage is to be able to pinpoint and trace the life cycle of a workflow from the beginning until the end. From the minute that I entered some parameters, trained the model, and then got an output, so that I can attach each model to its parameters, to its models. So let's imagine the best way, the rubric that we should follow, the framework that we should follow in order to actually achieve what we want. So in theory, we would want to have our inputs versioned. What do I mean by that? So if I'm going to run 0, 1, I am going to use parameter 1 and 2 and 3. Then there should be a known and reliable way of knowing that run 0, 2 runs parameter A, B, and C instead. So if I have that versioned, saved somewhere, a database, a Git repository, then I can track it back. Second thing, the pipeline itself. So whatever I'm going to run has to be versioned. I need to be able to know that this model was produced by this pipeline, and this other model was produced by another pipeline. So that even if the inputs are the same and the outputs are the same, I can know that this can be reproducible, but this is not entirely exactly like this, because we used another pipeline. Third thing, metrics have to be tracked. So I put some parameters into a pipeline, And then these gave me a model. Like we said, model underscore final underscore final, that thing. So we have to track these artifacts. We have to save them somewhere that are version as well, so that I can refer back to the versions and I can roll back if I want. What if I passed in some parameters, and then the model that got generated is buggy? It's not good enough. I do not want to push that to production. I need to have an automatic gate that would assess my model based on criteria and then validate whether this is actually a good model or a bad model. And finally, what happens if I have done all that, everything is fine, I generate a model, I put it on production, but I go on a sick leave next week. So my colleague takes over, and then they don't know what I have done because I just fell sick and didn't show up today. So they did something else, and then they pushed it to production. And now I come back from sick leave, and I don't know which model is deployed, what happened. So there is nothing that would denote my actual desired state that I want to be in the cluster. I don't know what happened when I was out. So we want to avoid that. So if we have something that audits my rollouts on the cluster, I can roll back. I can know that nobody tampered with my environment, that the state I want the cluster is in is actually the state that the cluster is in. So this is the framework. This is the framework that we wanted to talk about and have a mental model on. So up to now, we spoke about reproducibility. We spoke about how reproducibility would help with data leakage. We spoke about why we need reproducibility, what the teams struggled with, and the mental model or framework that we would like to implement. Let's go and think about how to abstractly implement that. So basically, we would like to go through a defined pipeline. So this pipeline is going to take it from the start to finish every single time in an automated way. First, I'd like to train the model. And to train the model, I will be able to track my parameters, track my metrics, log the artifacts that get produced, and log the metrics that are actually produced by this training. And then next, I will register that model. Why would I register this model? It's for versioning. So I would register version 1, and then version 2, and then version 3, and later I can roll back or I can compare them. Third, I'm going to validate that model. Do I want it? Do I not want it? If I don't want it, then I can just skip. Or maybe, like we do with, for example, security enforcements, I just want to audit what metrics are produced in a certain way, some quality checks, some audit checks. So this validate can be just there to log that for me so that I can compare if this is the actual correct threshold that I should put later. And then I can go into enforcing mode. Like, okay, if I get this value, then just drop. Don't continue. Don't build. We've reached to the build step. Now that we know, we love our model, we would like to build it. So this model is on a tool registered, and I would like to package it into a container to be able to deploy it finally on Kubernetes. So I use a container builder. I build this container, and then I have to deploy it. Again, like I said, if I just went and deployed it the way that we roll out deployments on Kubernetes, this is not tracked. So in theory, we need something to be able to continuously monitor our desired state and make sure that this desired state is actually on the cluster. I'll take a moment here, just look at that pipeline because we are going to implement it in a while. How can we implement that pipeline? This pipeline is a full pipeline that introduces the concept of MLOps. So in DevOps, we are actually actively producing applications and then deploying them. In ML, that's the same. We are training models and then pushing them to production, making them live. So it's the same. First, I'm going to have my orchestrator. My orchestrator here is Kubeflow. All the tools that we are going to be dealing with today are open source and cloud native. So it's accessible for anyone, and it can be scaled to any production. My orchestrator here is going to be Kubeflow, and it's going to do the full lineage for my pipeline from start to finish. How is it going to be able to do that? It's bundled already with Argo workflows, and it's bundled with ML metadata. ML metadata is going to make sure that everything along the way, from the minute I start a pipeline until it goes on production, everything is tracked, everything is known, so I can reproduce that later. And Argo workflows is going to give me a very important thing. It's going to divide my stages, like the train model, the register model, into containerized environments, so that each container cannot take a peek on the data from another container. And this will help us minimize or eliminate data leakage or audit it if it happened. Next step, we are going to use MLflow. MLflow is a nice framework-agnostic tool that we can use in order to plot our parameters, our metrics, our registered model, and serve that model at the end, and be able to compare runs, check everything that we have achieved so far in terms of machine learning. Third, we are going to use a versioned backend, min.io here, but for production, of course, we can scale that up to something like Amazon S3 or so. Next, we are going to use Canico for builds. This helps us build containers into a user space, because for Docker, we need a privileged container space, and this is not possible in Argo workflows. We are going to keep everything that we need versioned into Git. So the model serving deployment that we are going to have, we are going to leave it in Git or GitHub or GitLab or whatever software that we aim to use. And last but not least, we are going to have Argo. Argo is our hawk. It monitors our cluster. It sees if the desired state is different from the actual current state of the cluster. It detects drift. It auto-heals and syncs the models. And even if we would like to deploy a model, we are going to just add it here in the repository. Argo is going to pick it up, and then it's going to deploy it for us. And that's how we achieve a fully automated pipeline from start to finish that we can reproduce, that involves minimum human interaction. So I have spoken for a lot of time. I'm sure that some of you are getting bored, but we are going to get to the interesting part. We are going to see a live demo of whatever I have seen now. And we are going to try and do it together to see it in action. So here, I'm just using a dataset, an open source dataset. This dataset has 39 numeric features, and it's a simple dataset, a fitness dataset. So this fitness dataset, it represents the diet and heart rate and exercise data for human beings. It has 20,000 records, and it is an unsupervised, it's unlabeled, and the expected anomaly rate that we expect in this dataset is 5%. So inherently, when we train our model, we are going to ask it if the output is between 3 and 5%, sorry, 3 and 8%, then this is acceptable, else not. So this is going to be our validation quality gate. Again, this might look very, very simple, but this is the essence of the demo. It's going to be simple, but you can replace its parts because the framework is the same. The framework is going to always be the same, and you can replace tools, you can replace the implementation of each stage, but it's going to work the same, the very same. The architecture. It's a very big diagram. Let's go through it. So we have our training data here. Our training data is going to be mounted into our 5-stage pipeline. So if we can see here in the orchestration layer, like we said, Kubeflow is going to be our maestro here. So first, we are going to train an isolation forest model. And this is just picked, again, for the simplicity of it, for the lack of computation requirements of it. But you can change that. It's fine. Then we are going to register that model. And for both of these stages, we are going to use MLflow, like we said. Next comes our validate. We are going to validate the produced model, see if it passes our gate of 3 to 8%. And if yes, then we can proceed. If no, then we can halt. Next, we are going to build the container. Canico is going to build that container and push it to an in-cluster container registry. Again, let me remind you that this is a demo. We want it to be light for the simplification fact, but in a production environment, you would opt for something like GCR or Harbor or stuff like that. And then we are going to deploy it. How are we going to deploy it? Like we said, we do not want to just throw a model in Kubernetes and not know how this happened. So that deployment is going to go on Gitea, which is locally hosted on our environment. Gitea is going to see, OK, this is your new desired state, the new model. Well, this is watched by Argo. Argo is going to detect that you are trying to deploy a new model. It's going to sync it into the model serving Kubernetes deployment. And that's everything, how everything is monitored. ML metadata is watching like a hawk. It sees what happens from start to finish. Argo workflows is the execution engine, and it makes sure that no container would peek on the data of the other container. So that's how we just achieve our goal of having a fully reproducible automatic pipeline for ML workflows. That's a big architecture overview, but in a minute, we are going to try to achieve that together. And because this is a very comprehensive diagram, it has a lot of pieces, it has a lot of components, and it's going to be hard to deploy that with all of you each on local. So we have prepared a lab for you. So with the amazing help of my team in KodeKloud, we have prepared an environment for you here, a hands-on lab. This is the link. If you have your laptops, please get your laptops out if you'd like to follow along and access this. My team is going to be in their KodeKloud t-shirts, roaming around the room. If you have a problem, reach out to any of them. They are going to help you. And I'll just give you a minute or two to acquaint yourself, open your laptops, get everything running, and then we're going to start. I have the demo on my laptop. I'm going to share that, and we can work together. So just giving you 2 minutes, and let's get started. So since we are a lot of people here, if you face any timeouts, if there is a little bit of slowness, excuse the internet, and let's get around in retrying until that works, OK? So I'm going to put up on the screen the link again, just in case somebody missed it. And you should see a sign-in screen. If you're not signed up, if you have never signed up to KodeKloud, this is just going to take a minute or two. So get through it, and we can start. If you have any questions, either shout out or reach out to anybody that is roaming around you in a KodeKloud t-shirt. Let me try and open up the lab with you guys. So for the sake of this demo, we are going to run a pipeline together, explore all the aspects of everything that I have shown you. I'm just going to check with you, guys in the back, if you can see well, raise your hands. If you need me to crank up the font, don't raise your hand. OK. Is that better? Everybody can see? Thumbs up. Hey. People in the back. A little bit more? Bigger font? Guys, love me a little bit. OK? OK. Everybody ready? Or should I wait for a minute? Slightly larger? Slightly larger? Good? Good. OK. OK. So I'm going to go quite slowly. If you need me to stop for any reason, just wave or tell anybody. OK? So just to walk you through the environment that we have. So we have on the right-hand side some instructions that give you the overview of whatever we have been speaking about since this morning. Then we have VS Code environment on the right-hand side. The right-hand side is going to be our main environment. We will use the terminal to be able to deploy and compile pipelines and stuff like that. And we have some of our files that we're going to use. I'm going to show you around everything slowly, and then we'll have some time for questions at the end as well. Again, if you are stuck with anything, reach out to anybody that is roaming around you in a KodeKloud t-shirt, or if you're near me, just wave, I'll stop. OK. One thing, I'm going to be going to the laptop a little bit and coming back because of the interactivity. I'm a little bit short, so if you can't see me, it's fine. I'm not a ghost. So let's go through the instructions. So that is what is included in the lab. It's a full MLOps pipeline. So train, register, validate, build, deploy, the one that we have just been saying. GitOps with Argo CD to be able to push to Git and sync with Argo. We have an in-cluster Git server, and we have an in-cluster container registry. And we have ML metadata embedded in Kubeflow pipelines. We have Kubeflow pipelines, of course, MLflow, min.io. And we have 3 main files. We have the deploy stack. So I want to show you guys how the deployed stack look like, how everything is deployed, what different components that we have in here. And then we have a pipeline. The pipeline is already provisioned. You have the code. And by the way, this lab is going to be available on the same link until next Monday. So if you go home, you'd like to play with it, you'd like to break it, make it, that's going to be staying, so it's not going to go anywhere. And last but not least, we have a run KFP. KFP is Kubeflow pipelines, just for short. We have a run KFP PY that we are going to use to deploy pipelines on Kubeflow. There are 2 options, either CLI or GUI. You can try the CLI. I'll just give you a hint of the UI just because it's more interactive and good to see. There are some quick instructions here that are going to guide you with this lab if you're not in this session or if you decide to see it later. So first thing that we are going to do is copy this and paste it here and let this deploy. So like I said, let me just make this a little bit better to see. So this is going to deploy the infrastructure. It's going to deploy registry, min.io, MLflow, KFP, and GitOps. And while this is running, this is going to run like for 5 minutes or so. So while this is running, let me go and show you how this actually goes. Because, you know, it's going to take time, and I don't want to waste your time. So the first thing it's going to do is it's going to deploy a local container registry, and then it's going to wait for that registry to be up. It's going to configure min.io. It's going to wait until it's up, and then it's going to configure a bucket. And this bucket is called ML artifacts. We are going to use this bucket to save our modeled, our versioned models later. So we are going to deploy MLflow. We are going to point it to that registry of the min.io. And then we are going to crank up the Kubeflow pipelines. In an actual production environment, all these will be already installed. I'm just showing you the infrastructure just for your information. So Kubeflow pipelines are going to be taking some time. It takes a little bit to deploy. Once it's deployed, it's going to configure everything, service accounts, config maps, RBAC, everything. And it's going to later provision some persistent volumes. Again, this is a lab environment. That's why we're using persistent volumes. In a production environment, it's not wise to do that. Because you have multiple nodes, and you don't want something to be reliant on a node. You can use persistent volumes if it's like creating an external cloud storage, not a local one. For here, for the simplicity, we're just using host-based ones. After that, we are just giving some role-based access control access for Kubeflow pipelines to be able to navigate and manipulate the cluster. We are aiming to verify that our Git server is up, our Argo CD is up, and then we are going to push a base image deployment of the model. This doesn't have any containers running. So because it doesn't have any containers running, we did not train any models yet, so that's why. That's fine. It's not going to be a problem. And then we are going to train the model, deploy it, and see as the pods recover and the model is deployed. Last but not least, the Argo CD application. So we are going to create an Argo CD application to monitor our Git repository and be able to sync that. Let's go back to our lab. So for some reason, yeah. Let's give it a minute or two. So let me just recap what I've said while this is running. So for now, we have only set up the environment. We have installed all of our architectural diagram components. We have configured them to work together, but we haven't done anything related to the pipeline yet. So while this is deploying, let me show you the pipeline that we have. So this is a very, very long file. I'm not going to go through it all, but let's just, for the sake of showing you around how this looks. So this, again, because the font is big, let me just pop that out and show you in a better way. So this pipeline, it has the 5 stages that we said. First thing, So first thing is train, and then we have the register, and then we have the validate, and then we have the push, the build and push image, and then we have the deploy to the GitOps. So as per whatever we have discussed now, this train model should train the model. It's easy. And then register model should actually version and save my model into an artifact that we can refer to with versions afterwards. Validate is going to be the validation gate, the automatic checks that we are going to impose on a model. Build and push are going Kaneko is going to build us our container and push it to the in-cluster container registry. And then deploy model is going to deploy it to Git, and Argo is going to sync it. So we are not going to push it directly to Kubernetes, but rather we are going to deploy it to Git. This is going to be picked up and reconciled by Argo. Let's check one of these. So to start with, we have something called the DSL component. This is, I'm not going to go into details of that because this is Python and details. But just for you to get a rough idea, so the DSL component is going to install a container when Argo workflow cranks this stage up. So I'm going to spawn, or Argo workflows is going to spawn a container with these packages installed. And as you can see, each package is pinned to a version. So if I run this today, if my friend runs this tomorrow, MLflow is always going to be installed by version 2.17.2. which makes sure that we are not having any environment drifts, we are not having any package drifts. And then we get here, def train model. This is our stage, our first stage, the train model. And we have some parameters, and these parameters are going to be processed somehow. I'm not going to go into the code, but you can check it on your laptops. And then it's going to output something that we might use as an input for a future stage. Let's go back and see if our infrastructure has been deployed successfully. Great. So this is telling you that the infrastructure deployment has completed. The services available are these services. And then the next steps are the following next steps. Before we go further, I just want you to notice these links above. So these links above are our tools, KFP, Gitya, MLflow, and Argo CD. You can just click on that, and it's going to open the relevant window so that you can see the UI of the tool. They are exposed via node ports on production. Basically, you're not going to use node ports, of course, maybe load balancers or stuff, but for the sake of simplicity, we're using node ports here. If you scroll down on the left-hand side, you can see credentials if you need credentials for any tool as well. And let's go to our next step. Now we have the pipeline. We are going to compile it. There is a compile pipeline command, just Python 3 and compiling. Let's paste that here. And before I paste that here, I want to show you something. So on the left-hand side here, we don't have any YAML files, right? We just have a full pipeline.py. And Kubeflow pipelines do not work with Python. They work with YAML. So once I compile this, it is going to tell me that it's compiled successfully, and it's going to generate me the YAML file that I'm later going to use in Kubeflow pipelines. As I said, you can follow along with me. But as I said, you can use CLI or UI. CLI option is available here, so I can just take this command and run it here. But for the sake of visuals, let's see how this works with UI. I'm going to right-click on full pipeline.yaml, and I'm going to download this file locally. And then I'm going to click on Kubeflow UI. This is the UI for Kubeflow. So on the left-hand side, I have pipelines, experiments, runs, stuff like that. So I'm just going to click on upload pipeline there and call it KFP demo, and then upload the file that I just downloaded. And you would see that this is full pipeline 6 because I have downloaded this a lot of times. And then I can click create. Once I click create, you can see this lovely diagram. So this lovely diagram in Argo workflows is called a DAG, if you know anything about Argo workflows. So DAG is directed acyclic graph. Directed acyclic graph means that every step is going to have a relation with another step. So for example, here, as we can see, this train model is going to give an output to the register step. It's going to give another output to the model step here. And then this register model step is going to output something that is going to go into the model, the validate model. This validate model is going to either succeed or not succeed, but it's not going to give any outputs. And then once this succeeds, the build and push is going to be cranked up, and then this outputs the image that it generated to the deploy model GitOps pipeline, and that is going to give my image into the desired state of the cluster, which is Git. Argo CD is going to pick that up and sync it to the cluster. Let's go and create a run. So up top, you have the create run. Click on create run. And you would see here all the run parameters. Let me crank up the font. So you would see here the run parameters. So all these are things that we can modify. We can change the gate, anomaly max rate, anomaly min rate for the validation later. We can change passwords and usernames. Of course, in a production environment, we are not going to have passwords like that. This is not good. We are going to use Kubernetes secrets in a different way, but just for the sake of simplicity and you seeing that it's in plain text here. Contamination is something that we can pass as a parameter to a model to see and vary different contamination rates and see if the anomaly rate is going to be cranked up or down. The data path, our fitness data, and some more parameters. You can see here something called the random state. Random state is used in machine learning just to make sure that every time I'm going to give these inputs with this specific seed, the output is going to be the same. So it ensures reproducibility in a machine learning sense of thing. So I'm not going to change anything. I'm just going to go with the defaults. If you would like to change anything, feel free to. But don't change passwords because this is going to break them. And let's start this. So this is going to give to move us to the run tab. And the run tab is just an instantiation of whatever we had. So we had the pipeline, we have the rubric that we have, and then we instantiate an instance from it, and we pass some certain parameters to it, and it's going to pass these values throughout everything and show us the actual output. This is going to take like 2 to 3 minutes. So while this is running, I have prepared some run that already finished, and let's explore it while this is happening. So after the whole pipeline is finished, you are going to see, so up top here, beside the pipeline name, you are going to see a small dot. This dot can be blue, which is indicating that this is running. It can be like a clock, and this clock is like it's scheduling. It hasn't started yet, but it's scheduling. Or it can be green, the pipeline has successfully completed, or it can be red, this pipeline has failed for some reason. And then for each stage, you are going to see this green tick if the pipeline is finished and successful. It can be like, let's see it in the other instance. So it can be like this loading thing if the stage is still running at the moment. And the beauty of Kubeflow pipelines is that you can just click on this, and you can see all the parameters that I entered. So these are the parameters that I entered: the contamination rate, the N estimators rate, the random seed, everything. And then I can see an output here. This output is going to be something called a run ID that I'm going to feed later into the register to make sure that this is the run that I would like to register later. So this model is going to be used for registering. And I can click on logs here and see exactly what input parameters did I have, what outputs did I see, what are the artifacts, what is the generated model, everything. So you have everything logged. Everything is tracked, and this UI is all because of the beauty of ML metadata that is embedded inside of Kubeflow pipelines. And each one of these run in a separate container, like I said. So the train model is running in a container, the register is in another container, and every single one of these is in another container. This folder that you can see here is dropping all the models versioned onto min.io. And this can be a 3, like I said, it can be a 3 bucket, it can be anything that can version models. So let's just take a look at the inputs and outputs. I don't want to worry you with a lot of logs, but you can have a look on your side. So the train model is going to generate the run ID, like we said. This run ID we are going to feed into the register. So if I look here, it's the same run ID. So it started with CAA, it's still starting with CAA. So the register knows that this run that had the run, CAA, whatever, is having a model as an output, and I need to register this. And it's going to give me a number. This number is the version of the model. So first, it would generate V1, second, V2, third, V3, stuff like that. Now, I'm going to validate this model. So as you can see here, this model failed. It has an anomaly rate of 50%, and this is outside 3 to 8. So this is not what we want. We want it to crash. We can want it to be like that in case we are just running to make sure that we log everything and later on decide on the threshold that we want. So for that sake, I didn't make it crash, but we can see in a bit how to make it crash. And then you have the build image. The build image took the model name, it took the registry that it's going to push to it, and it's going to return a URL for that image that it's going to do. So I took a version 2 model, and I generated model-serve :v2. So that's the new image that I'm going to push to my registry. And this we are going to use to update our GitOps. So we are going to push these things. We are going to push that into the GitOps, and we're going to see that in a bit. So we're going to open all the UIs and see that in a bit. Is that fine? Does anybody have any questions so far? All good? OK. So let's go and see that pipeline that we have run. Sometimes you need to reset or restart the pipeline or refresh or wait for it to refresh because it's a little bit not real time. So if you click on something and you see error, it cannot retrieve the pod logs, just give it a refresh or wait for a few seconds. It's going to give you something. So this is still, like I said, this takes a little bit. So this is still on the image and push. So let's go back to my pre-run. And if we go here, we can go to runs. And we can choose 2 runs, for example, and we can just click compare runs. So compare runs can actually tell me that on the first run, I used a contamination version, a contamination of 0.5, which is different from the default value. So it keeps track of the default values. It does not output automatically all the default values. So the default values are staying default, and it just gives you an idea of what changed here. So on this run, I changed 0.5 for the contamination. For this run, I changed a 200. And like I told you from a bit, we can actually use the validation gate as a make it or break it. So what I did here for the third run is I added these lines. Let me get you the code. So I added these lines here in the validate model. If we scroll down, back then, these lines were not there. So I just told it, if the decision is failed, just raise an error. And that breaks the model, the pipeline at this stage, and it does not advance to the build stage. So when I compile and run this, you are going to see something like, you're going to see something like this. Again, give it a second. Validate model, and I can see the logs for that, and this is going to tell me this is an error. The validation failed because the anomaly rate is outside the range of 3 to 8%, and it's not going to deploy this model. It's just going to stop there. So for now, we have explored Kubeflow pipeline. Let's check the other views. So Kubeflow pipeline, like we said, it's our maestro. It orchestrates everything. What if I would like to compare the experiments that I've run using MLflow? So let's open MLflow. MLflow is here, and we can just go to the model training tab. So if we can just click on the model training tab. And then select that KubeCon demo that I have, experiment that I have set. Because I have ran this in the background, I started that before the demo. I have 2 runs, not just one. So we can click on the checkboxes here and then ask it, can you compare these runs? So it gives us some metrics. It gives us the parameters, the metrics that we are going to compare with. It gives us like a nice diagram here. And you can check the run details, so the run IDs of each. CAA is the one that I showed you from a bit. And then the run name. This gives it a funny name that is auto-generated. This is not me. And then the start time. When did this run got executed exactly? And then the end time, when did this run end exactly? And then how much time did it take? So it took 3.5 minutes here. And then you can go down, you can see parameters, and you can see I ran here a contamination of 0.5, here an 0.05. So this is the one that failed later, the one that I crashed the validation on purpose for. The N estimators changed here, the N features changed here, and you don't have to worry about the numbers here. So these are just for demonstration purposes, and these are going to be relevant per data set. So this is just for demonstration. We are not focusing on machine learning here. We are focusing on the actual framework. Metrics, the same. Anomaly rate here is 0.5, which is 50%. And anomaly rate here is 0.05, which is 5%. This is the accepted model that we have. Artifacts is going to show you all that. In models, we can view the models generated by a run. So I can click on the run, and then I can move to model registered here. It's going to open my model registry. And I can see that this is the anomaly detector model. I'm keeping the name the same, but I'm changing the versions. So this is version 3. The last one that I registered is version 3. And I can see previous models. I can roll back. I can do that. So that's for MLflow. Let's check GitOps. So let's check Gitya. As I told you, if you scroll down there, you can see the credentials for logging in. So this pipeline that we have been running is finished. So this one that we have just cranked up a little bit from a little bit, it finished. We can check what happened here. Let's go to the lab and click on Gitya. The first time you open this, it's not going to be logged in. So log in. The username and password are MLOps and admin123. Again, if you can see here, this is a created repository that was created 19 minutes ago. This is when I launched the lab with you. So this is an initial commit that happens every time you crank up the lab. So this created a directory, a repository, sorry. And then later, if you can see that from 4 minutes ago, it deployed model version 1. And if we can see that, we can just go to the repository. We can go to the model serve deployment. So this is the deployment that we are using to serve the model. I can click on this. Let me just close these. I can click on this, and I can do a history for the file. And I would end up seeing two commits. The first commit is the initial commit, lab startup. And the second one was done by Kubeflow pipelines, the one that happened when we ran the pipeline. And it deployed model version 1. If we can check here what happened, what changed. So this added some annotations. it said that this is deployed at this timestamp. It was deployed by Kubeflow pipelines, and it has model version 1. And it changed the registry down. So the new image is going to be this one. Localhost is because the registry is deployed localhost. This is going to be your production registry if this is in production. So now I need to go to Argo, and I need to log in. Again, the logins are in the lab, but it's admin123. Okay. If I clicked on that, it's going to show me that I have a synced status. So my application is healthy, my model is healthy, everything is healthy. The sync is OK. And this succeeded 6 minutes ago. Again, this is when the pipeline has finished. And to make sure that this is that, if you see the last author, it's Kubeflow pipeline, and it's the same commit that we saw in Git, it's deploy model version 1. And if we can see here, this is my deployment. It has 2 pods, and the 2 pods are up and running. And we can verify that from the CLI. I can just come here and click kubectl, get pods. The models are served into the default namespace. So we can see here 2 pods, like we saw in Argo. And these 2 pods are in the running state. So what if I want to query that? So I would like to query the model and see if it gives me a prediction or not to make sure that this is actually working. So if you scroll down here, you can see that there is a command that I gave in the lab. This command invokes, it gives a row to the model, and it queries whether this is anomalous data or not. If it's anomalous, it gives me a -1. If it's not, it gives me a 1. So if we can run this here, again, the sample data is given in a file, if you can check the VS Code. But this sample request.json that I'm giving should actually be a good data. So just to give you an idea again on that, it's the data for a 35-year-old healthy person that eats fine, that has good training data. So there you go. You have predictions equal 1. So now, let's just recap everything that happened. We went from giving parameters to training the model to reproducing everything without any human interaction. We have succeeded to be able to achieve all these steps in a very automatic fashion, and we can reproduce this. So you can, on your laptops, you can run another run with the same parameters and see if that model is actually going to be reproduced or not. So let's go back to our slides, because I would like to give you some key takeaways as we are approaching the end of this talk. So 5 key takeaways from this talk is, if we would like to achieve a fully automated, reproducible machine workflow, we are going to follow these 5 rubrics. First one is to pin everything. As we saw, all the packages, everything, the environment, everything is pinned to a certain version. And every time you're going to run your pipeline, this version is going to deploy. Second thing, track lineage. So the lineage is the most important thing for you. ML metadata achieves that for us. You know what goes in, what happens, and what comes out every single time. You are auditing everything. GitOps. This makes sure that nobody messes up with our production or our environments. This makes sure that our desired state, our wanted state, is the one that always runs in production. Validate before you ship. Make sure that your models are not faulty. Make sure that you run tests, extensive tests, and break before, if that is not what you want, break before deploying it to production. Finally, immutable artifacts. Make sure that if you are using Git, if you are using versioned S3-like storage, everything is going to be the same. It's as if you're writing with a pen, not a pencil. Nothing can change. Everything remains the same. Everything is the same every time. And that's, guys, how we achieve a fully reproducible workflow using Kubeflow and using the help of Argo workflows and ML metadata behind the scenes. Again, this is Nourhan Mohamed. Thank you so much for being here. I am very grateful for you as an audience. And last but not least, some questions. These material are all available in the GitHub repo. I'm going to upload the presentation to the SCED QR. Please leave me a feedback. I'd like to improve on everything. And if you have any question, please, we have some time, so shout out and we can go ahead. Yeah. Thank you. Anything? Sorry, yes? Yeah, sure. Yeah.
Okay, thanks.
We actually have people with the yellow shirts, they have microphones, so you can keep
Yeah, thank you very much. It was super nice. I was asking myself what you need on the cluster side. So you have all the installations I saw quickly for Kubeflow, of course Argo you showed. What else comes into it that would be cool to get answered? And just quickly a second one. And also for MLflow, for example, like in our case, what we intend to do is host it also centrally. And I guess, yeah, Argo is also the same, all these things. This would also fit in the same category, right? We could do the same.
Thank you for your question. So for your first question, I am using a very basic Kubernetes deployment in the background. So everything that we deployed is in the deploy script. Nothing is different. It's just Kubernetes version 1.34 in the backend. And then we deploy everything in the script. So nothing is hidden. Everything is there. For your second question, like you said, if we centralize everything, we are having everything passed as a parameter or embedding everything as in the pipeline. If you go through the pipeline, you would be able to either tweak the parameters to be able to add your external repository, for example. So we're having here an in-cluster Docker repository. If I have Harbor, then I have a link. I can change that. If I have an externally hosted Argo, I can change that. So this is going to roll over for anything that is centrally hosted. We are just using a mini version for our demo just for the sake of it being light. Yeah. Did that answer your question? Yeah. Thank you. Yes.
Hi, good afternoon. My name is Wienand, and I saw your presentation, and I think it was a very, very good, actually excellent analogy with the comparison with a chef that is preparing a certain meal, and I think that was very clear to a lot of people. So thank you very much for that.
Thank you.
You're welcome. And what struck me was that you said, well, there was another day. I think it was Bob or Rob that.
It was Bob.
And then there was another chef, but then it was very clear to me that you said, well, he used the same oven, and there I think, well, perhaps when you're using Kubernetes, that might be true, but in other cases. It is also very important to use exactly the same hardware.
Definitely, yeah.
And there could have been another oven.
Of course, yeah. So even in Kubernetes, you might have different nodes with different GPUs, and this is scheduled on that node, this is scheduled on that node. So it's important to keep track where you are actually scheduling your workloads, which is going to be given to us here by the lineage as well from ML metadata.
So I was just wondering why you haven't touched upon that part of the reproducibility aspect of also perhaps drifting or deviating away from certain hardware aspects, and that could also result in a different result when you're keeping all the other aspects constant.
Yeah, so just to reiterate, in my example, I just said that they use the different temperature, but it applies the same. So if you use the different oven, if you use the different temperature, this all comes into the pinned versions. So, or the pinned hardware, or the different hardware that you can use. So your point is very, very valid. That's true. If we are running on different hardwares, we need to be able to actually track this and make sure that it's the same in each time to be able to compare both runs.
And I'm a very, very novice person when it comes to Kubernetes, but what is there in place to actually make sure that that aspect is also reproducible?
So first off, you can choose to run your workloads on a certain node, so you can enforce that. You can use taints and tolerations to be able to know that all these workloads are going to be scheduled on, for example, these GPU nodes. All the others are going to be scheduled on other GPU nodes. So you have some Kubernetes-specific configuration that you can have in place to make sure that each workload is going to be scheduled somewhere in general. Or you can go full separation and schedule each workload on different clusters. So you have a cluster with high CPU and high GPU. You have a cluster with medium. You have a cluster with low. So both works.
Thank you very much.
You're welcome. Thank you. Questions? Did you guys enjoy the lab? All good?
Hello?
Wave to me. Love me, guys.
Sorry, also one question from me.
Yep.
Thank you so much for the presentation.
Thank you.
So I'm not really a machine learning engineer, but it was very interesting to see the whole flow. But I was wondering, how relevant would this be if you would be using the same model, but you would be comparing two different data sets together?
Well, I wouldn't advise comparing different data sets together, because you would generate the same thing for the same data set. As you see, I didn't change the data set at all. But if you change the data set, your output is going to be different, but maybe this is the use case for your company. So maybe we get output from, for example, Garmin watches in comparison to Apple watches, in comparison to something else. So maybe you are going to gather that and see the mean variance or anomaly rate in Garmin versus Apple versus that. So this can be a use case depending on the use case that you want to implement for your business. Yeah.
Thank you.
You're welcome.
Yeah,
Hello.
Thank you for the presentation. It was really interesting. We are also using Kubeflow in our company, and I wanted to know how can we configure the pipeline to use the GPU for LLM fine-tuning, for example.
So you might not want to configure the actual Kubeflow to that, but you can enforce taints and tolerations. You can also use node selectors in the pipeline. I'm not proficient in Kubeflow, but we can check this together after the call and see what's the exact Python scripture that we need to use to enforce this. But this is definitely something that we can enforce to make sure that these kind of containers run on a certain node selector.
Thank you.
You're welcome. Thank you. Any other questions? All good? All good? Counting down, 3. Thank you all. It has been my pleasure being with you here. Thank you so much for your time, and I hope that it was an interesting presentation. Thank you so much.